I do have my, it's kind of late, but I do have my sketch pad now, and there is basically the graphic I was trying to show you about, finding the tangent line at any point in space. Where you're going with this is like Calc 2. And for some of y'all that goes into engineering, it'll be Calc 2. You'll see some of this in your Math 230 also. And, finding the derivative is finding that black line, the equation for that black line at any point on the curve. And you can also see it with this one. And let's just add segment x plus h. There's x plus h. I don't understand this. I tried to extend it, but it won't extend, so I don't know why that don't work. So I don't know why that don't work. And then call that point Q and draw the secant line. There's your secant line. And then basically converge. And when you show the convergence, you see that the secant line becomes a tangent line. And you see the squeeze theory here where the x converges, so does the f of x. And you see that basically convergence right there. That's the limit theory with your difference quotient. And basically you're turning the secant line into the tangent line. Everybody see that? Hopefully that helps you out. It's easier to show you when I have this, and I didn't have this on my computer the other day. And because I got a new computer and they didn't install everything that was on my old computer. So I had to get them to fix it. So hopefully that kind of helps you see what you're doing. And once you find this, once you're able to find that black line right there, then you can do this, which is, let's see, where is it? Yeah, right here. Then you can do this. You can do that. And when you get to second calculus, you can do it to any point in space. And a lot of people say, well, Hubert, why do you want to find the tangent line? Well, I'm going to pause it. Once you find the tangent line, you can find the normal vector, which is the line that comes 90 degrees off the tangent. And that means something also. So hopefully you see a little bit better. There we go. And that's why you need to learn the limit theory. And what you're learning with the limit theory is what is happening to y as x is moving. And that's not what, you're not used to that, because in algebra, x is not moving. X is a single point. And now that you see this, hopefully you can understand what the difference is between algebra and calculus. In calculus, x is moving. And in algebra, it's not. It's just one single point. And in calculus, it's moving. Yeah, that helps out a lot, Hubert. Good. Thank you for the interaction. I appreciate that. Anyway.
Thank you, Hubert.
You're welcome. All right. So here we go. Y'all just don't know how to appreciate good teaching. That's basically it. You'll appreciate it next semester when I hear the belly aching. All right, 1.2, 25/11. 1.2, 25/11. I have no idea. I haven't looked at these. So it says objectives use limit properties to calculate the limits. First of all, is this a test question? Yes, it is a test question. All right. First of all, this is the difference of two cubes. This is nothing, but you have an undefined function at 10. So you might as well go ahead and write that down. Limit as x approaches 10 of x to the third minus 1,000 over x minus 10. So the first thing you're going to do is make a note, and I told y'all to do this when we did the problem. We did this problem in class. There is an undefined function at x is equal to what? 10. So there is an undefined function at x is equal to 10. That means that your your domain is all real numbers except x cannot equal 10. And you have an open circle on the graph at x is equal to 10. Now, before we even start the problem, you need to acknowledge that. Now you're going to use your algebra, which is shortcut number 5 on the top, which is x minus 10 times x squared plus 10x plus 10 plus 100 over x minus 10, and limit as x approaches 10. Well, what happens with the x minus 10s? They cancel, Hubert. And that leaves you with limit as x approaches 10 of x squared plus 10x plus 100. And that's going to give us 100 plus 100 plus 100. And what's 100 plus 100 plus 100?
300.
300. And yes, this is a test question, so make sure you know how to do it. So we go to our handy dandy and put 300. And we feel good about ourselves. That's the type of question I would pick for a limit question because it's short and what? Sweet. There's not a bunch of Philadelphia lawyer questions. There's not a bunch of what is the addresses of people that's attended Wimbledon. I mean, there's not 15,000 parts. There's not Philadelphia lawyer questions. It's just short and sweet. Good question. Good test question. Which I'm not going to pull a lot of questions out of 1.2 through 1.3, but hopefully that helps you. This one is that was 1.22511. This is 1.23613. First of all, is it a test question? Oh yeah. Go ahead, if I was you. Now this is infinity, so I would probably divide by x cubed all the way through since you're dealing with infinity. And we did a problem like this. This is a good test question. So limit as x approaches infinity of 40x cubed plus 5x squared minus 4x over 32x cubed plus x squared plus 3x plus 2. Now there's two things to tell you to divide by x cubed. One, it's dealing with infinity, and 2, you just got a whole mess here. You got trinomials all over the place. You got x's on all 3 terms. So this is confunction junction, and you got a infinity right there. So I would divide through by x cubed. So 40x cubed divided by x cubed plus 5x squared divided by x cubed minus 4x divided by x cubed. And yes, I'm doing it step by step because I don't want to make a careless mistake. I don't think I know everything, so I don't try to do everything in one step. Plus x squared divided by x cubed plus 3x over x cubed plus 2 over x cubed. And that's going to leave me with 40 plus 5x, 5 over x, sorry, minus 4 over x what? Squared over 32 plus, that'd be 1 over x plus 3 over x squared plus 2 over x to the third as x approaches infinity. That's going to give me 40 plus 0 plus 0 over 32 plus 0 plus 0 plus 0, which is 40 over 32, which is equal to what? Let's see, 4 will go in there 10 times and there 8 times, and that's going to be 5 over 4. Y'all check my math. Oh, I didn't turn on my video. I'm sorry. I don't want to be a hypocrite. So, does 5/4 looks good? Thank you, Miss Holcomb. I have to switch back and forth because y'all not going to talk to me, so y'all will send me messages, so I got to go back to the chat. So, I got 5 over 4. So, I'm going to go back to the handy dandy question. And it says, I don't see anything that says, let's type in 5/4, so it probably won't like that. Oh my God, it actually took it. Okay, good. We feel good about ourselves. Who's got a question on that one? Again, that's a good test question. It's also a good standardized. Both of the questions that were sent today are good standardized questions and good test questions for 1.1 through 1.3. Y'all settle down, please. I'm going to delete that one and delete that one. This is 1.241/14. I feel like I'm doing y'all's homework. 11, 13, 14. Come on, y'all. I'm kidding. Oh, yeah, that's right. Y'all don't have a sense of humor. All right, limit as x approaches 1 of the square root of 4x minus 3. This is a radical. So first of all, we have to find out, we've got a horizontal shift of 3 to the right. So we know that the domain is affected. We can't use anything. Let's set the denominator equal to 0. 4x minus 3 is equal to 0. 4x is equal to 3. X is equal to 3/4. So we know at 3/4 we get 0, which is okay. We can have the square root of 0. We just can't have negative. So what is below 3/4? Well, 0. 4 times 0 is 0 minus 3. So we can't use x has to be greater than or equal to 3/4. So we can't use anything. 3/4 is about all we can use. So x has got to be greater than or equal to 3/4. So that's pretty much going to be your answer as far as when it says x approaches 1. As x approaches 1, 4 times 1 is 4. 4 minus 3 is what? 1. The square root of 1 is 3. I thought we were graphing this. I'm sorry. So 1. So as x approaches 1, y will be approaching what? 1 also. Because 4 times 1 is 4. 4 minus 3 is 1. The square root of 1 is 1. So your answer should be 1. And you should feel good about yourself. Another good test question. I could put all 3 of these on the test, but I would probably put those 3 questions in a pool, P-O-O-L, and let the test pick from those 3 type questions. That's probably what I do, because I'm not going to give you too many questions out of 1.1 through 1.3. And yes, I keep saying that over and over because I have to, because I'm a teacher and you are what? Students. So I have to repeat things, even though I can't stand it. Fun teaching class. You know, if y'all gonna start a revolution, how are y'all gonna start a revolution when y'all can't talk to people? And 1.3, 21/3. What?
We'll just be good old passive aggressive revolutionaries.
Yeah, there you go. That always works good. Passive aggressive works great in any type of relationship. You're going to text your revolution is what you're going to do. All right, so here we go. F of x is equal to 2x squared, and this is a test question. I will make sure, well, I don't like the way they do it. We're not going to do this. We're just going to do this, okay? So they want you to use the difference quotient and find basically the derivative of 2x squared. So, which is 4x. I can go ahead and tell you it's 4x. But we're going to go ahead and we're going to do it like they want us to do it. So this is going to be m is equal to f of x plus h minus f of x divided by h. Now we're going to kill 2 birds with 1 stone. We're going to do the algebra, and then we're going to apply the limit. So I'm going to give you 2 answers, and then I'll tell you which one to punch in. But this is two test questions. Finding the derivative and finding the difference quotient. Difference quotient is in 1.1 through 1.3. And then applying the limit to the difference quotient, that's 1.4. So this is we're going to kill 2 birds with 1 stone on this one. So 2 times parentheses squared, that's 2xh, 2x squared, minus, and there's brackets there. And then, of course, f of x is 2x squared, all over h. And we're always going to plug in an x plus h here. And that's going to give us shortcut number 1, 2 times x squared plus 2xh plus h squared minus 2x squared over h. 2x squared plus 4xh plus 2h squared minus 2x squared over h. And the 2x squareds do what?
Cancel.
Hubert. Thank you. And I'm going to go ahead and cancel that h right there. And cancel, make 1h right there. So 4x plus 2h is our algebraic answer. So that's the answer they want for this homework question. But we're going to go ahead and do 1.4. So I'm going to add, so we're going to do limit as h approaches 0 of 4x plus 2h. And what is 4x plus 2 times 0? That's 4x plus 0, which is 4x. So that is 1.4 answer. So you will see this in 1.3 testable material, and you'll see it in 1.4. The only difference is in a 1.4 question, you have to do all of this, and then you have to take the limit. So this is the answer to the homework question. This is what you do in 1.4. So we're going to type in 4x plus 2h, unless they want you to do the limit. Let's look at the question again. I'm just going to do 4x plus 2h. They may want some long drawn out answer over here, or they may want you to plug in. I didn't think about that.
No,
They may
4x
want
plus
you to plug
2h is
in the
right for the
numbers
first
here.
one.
I'm sorry, what?
I said 4x plus 2h is right for the first one. I think on step B is when they want us to plug it in.
Well, I don't know what they're doing on that, but so 4x plus 2h is what they want here.
Yes, sir.
H. Okay. Well, x plus h, so that's going to be 4 plus 2 is 6. I don't know what they're wanting here. Let's see what they're doing. They're plugging those numbers in. There's what I did. I've never done this before, so that's why I'm... Yeah, they're plugging them in into the x plus h. That's what they're doing. And that's what you got to do. So let's take let's go over here. I'm sorry, I didn't. So we've got 4x plus 2h, and they want 4, 2, 4, 1, 4.1, and 4.01. They're just showing you the limit rule, the squeeze theorem is what they're showing you. All right, so 4 times 4 plus 2 times 2. 4 times 4 plus 2 times 1 is converging. 4 times 4 plus 2 times 0.1, and 4 times 4 plus 2 times 0.01. 4 times 4 is 16. 16 plus 4 is 20, right?
Yeah.
And 16 plus 2 is 18, and you're going to see it converging. 16 plus 2.1 is 18 point, let's see, 2 times 0.1, 2 dimes is 20 cents. So 16.2, y'all check me, 2 cent, 16.02, and it's converging on 16, this looks like. You go from 20, so it looks like it's converging, and you can carry it one more. That's going to be 16. It's going to be 16.002. It's converging on to 16, and that's what they're trying to get you to see. Is this a good test question? No, I probably would not put this on a test. The first part I would. That part, yes. 100%. This part, no. So let's put the answers. Let's see what I got. Let's see, 20, 18, 16.2, and 16.02. And hopefully we feel good about ourselves. Good, no sunglasses inside. So whoever sent that question, the first part is a good test question. I probably would not ask you to do this on the test. Maybe I should quit telling y'all what I put on the test. Maybe I should quit doing that. 1.4, 60/19. All right, this is a piecewise function. Yep, that's what it says. Determine the values of m and b that makes f differentiable. What? At x is equal to 1. Why do they? You know, I tell y'all that some students can break an amble with a banana. Sometimes this book can make things more difficult than it is. Let's just see what's happening. I have no idea what they're asking here, but I'm going to draw it because I want to see what we're dealing with. And that's a good thing to do whenever you're confused. So mx plus b. Y is equal to mx plus b is a straight line, and x is equal to, or x can only equal or use numbers less than 1. So here's 1. So we can use 0, 1, -1, -2, -3, and so on. So we know that that line, we don't know where it's crossing. We know that 4x squared, we know what that looks like. We know that's a parabola. So I'm going to write mx plus b, and I'm going to put x is less than 1. That's black. And then red is going to be 4x squared. And that's going to be x is greater than or equal to 1. So we can't use 0. We have to use 1. 1 and 1. Let's see. 1 times 4 is 4. 1, 2, 3, 4. And we know, let's see, 2 squared is 4 times 4 is 16. So at 2, it's going to be 16, which is way up here. So we know that this parabola goes here, but this is the only part of the parabola we can show like that, and it's going up because it, I want to just draw a little. There. Oh, sorry. There we go. Everybody with me so far? And I can tell you right now, this is not a test question because they're going around the world to show you something here. So there's the red, and we can only do 4. This one right here is a standard form of a line, and x can be less than 1, so we can use 0. We don't know where the y-intercept is, but it's just a standard form of a line. So I'm going to use 0. I'm just going to use 0, and we know we can use 1. We can't use 1 here, but we know that it's going up here. I'm just going to draw a line, a point right there, open circle, and then just draw a line like this in black. And I'm going to leave that circle open because I can't use 1. And we know y is equal to mx plus b is a line that looks like that. Now, determine the values of m and b that make f differentiable at x equals to 1. I have no idea what this question's asking. I have no idea. So I'm just going to be honest with you. I don't know what they're wanting. I'm looking to see what they're wanting. Looks like to me they're going to set it equal to 5x squared. Yeah, x plus h. Well, why don't they just tell you to take the... It looks like to me they're putting... It's going to be 10x. There's 10x right there. I'm looking. They're basically wanting you to find, they want you to find the derivative of both of these. It's ridiculous. This is not a good homework question. F of x plus h minus f of x would have helped if they would have put this in the directions. Over h, limit as h approaches 0 of, and I'm going to put mx plus b and 4x squared. Now, of course, the first one you can do without any problem. This one you can do without any problem. So f of, so that'd be 4 parentheses squared, and plug in x plus h minus 4x squared over h, limit as h approaches 0. Well, we're going to get 8x is what we're going to get. So I can go ahead and tell you right now that we're going to get 8x for that one. So here we go. 4 times x squared plus 2xh plus h squared minus 4x squared over h. And that's going to be 4x squared plus 8xh plus 4h squared minus 4x squared over h. The 4x cancels, and that leaves us with 8x plus 4h. Limit as h approaches 0 would be 8x plus 4 times 0, which is 8x, which is what I told you we would get. All right, so that's that part. So I'll give you a second to write that down. Okay, everybody got that? I need somebody to say yes or no.
Yes, we have it.
Thank you. Okay. Limit as h approaches 0 of x plus h minus f of x over h. So I'm going to rewrite m times parentheses plus b minus mx plus b over h. And I'm going to plug in x plus h. And that's going to give me, let's see, mx plus mh plus b minus mx minus b over h, limit as h approaches 0. And the mx's are going to cancel. and the b's are going to cancel, and you're going to get limit as h approaches 0 of m is equal to m. So with one, you get 8x, and the other one, you get m. Now, I don't know what else they want you to do after that. I guess you're going to have to plug in 1 or 2. Let's see. Let's see what we're going to have to do this one together because I have no idea what they're asking. Okay, f of x plus h. We type in, I got what? 8x? Okay, they want us to do it step by step. Okay, whatever. 3, 3. I'm skipping through the steps. That's what I'm doing. And continue, and continue, and continue, and you get 8x. I hope everybody's following along that I just skipped through all that stuff. All right, there's 8x. And f prime of x is equal to 8x. And then we're going to plug in mx plus b. We'll put a 3 there. And we should get m. And limit as x should be m. There. So everybody see where we got 8x and m? Hopefully y'all see that. There is m. That's how you get m. And that's how you get 8x. So the first thing you got to do is differentiate using limit as h approaches 0 and the difference quotient with mx plus b and 4x squared. So that's the first thing they're asking us to do. Now they're going to ask us to plug in some numbers, and I think it's going to be 1, 2, 3, and 4, but with the way they have things written, I don't like this question. Okay, simplify, yeah, plug in. 8x are equal to each other, so 8 times 1 should be 8. Yeah, that's what they're doing. Okay, so let me see if I could get this. Let's see if I can figure out how to explain this. 8x is equal to m. Well, that's by what we've just, because the slope of the line is equal to the slope. That's what they're telling you there. Slope is equal to slope. You just bear with me a minute. I'm trying to figure out the best way to explain this to y'all. Therefore, 4x squared is equal to mx plus b. mx plus b. And 8 is equal to m. So you plug in 1, that's going to be 4 times 1 squared is equal to 8 times 1 plus b. And that's going to be 4 is equal to 8 plus b. B is equal to negative 4. Should be your answer. 4 times 1 is 4, and 8, and b is equal to negative 4. Yeah, this is, they're telling you, yeah, that's what they're doing. You're trying to find, okay. This is what they're telling you to do. Use 4x squared to find mx plus b. That's what they're telling you to do. Use 4x squared to find mx plus b. The first thing you do is you differentiate with limit as h approaches 0. Okay, differentiate both with difference quotient. The second thing you do is you set the derivative of this. So I'm going to say 4x squared prime equal to mx plus b prime. You're going to set those two equal to each other. Therefore, 4x squared is equal to mx plus b, and you're going to plug and chug what they give you. In this case, x is equal to 1. And you're going to solve for b. 3, solve for b. That's how you do this problem. And I'm going to ask who sent this problem, because this is not a problem I would give you. Miss Hollister, this is not a problem I would give you on a test.
Okay, good, because I was very confused.
Well, hopefully, are you confused now since I wrote it out a different way?
No, I get what they're asking now, but they just went like around the world for like a simple answer that they didn't really have.
That's what I don't like about these questions. Some of these questions, what this right here, you might as well get a Philadelphia lawyer to figure that out. Now, at this point, they're giving you 2. All right, so instead of plugging in on this problem, you're not going to plug in 1, you're going to plug in 2. So you would, let's go ahead and try this one, just to see if we understand it. So we got 2 lines, mx plus b, and then we got x squared. So f of x, so that would be parentheses squared minus x squared over h, and m times parentheses plus b minus parentheses mx plus b over h. And we're going to plug in, we're going to plug in x plus h. And x plus h. X squared plus 2xh plus h squared minus x squared over h. The x squareds cancel. And that cancels with that one and leaves h. So it's going to be 2x plus h, which is going to be 2x. 2x plus h, limit as h approaches 0, is going to give you 2x. And mx plus mh plus b minus mx minus b over h. And you're basically going to get m. The x's cancel, the b's cancel, the h cancels there, and you're going to get m. So limit as h approaches 0 of m. There's no h, so this just goes away, and you're left with m. So since we know that 2x is equal to m, we know that x squared is equal to mx plus b. So x squared is equal to mx plus b. And they tell us to plug in 2. They tell us to plug in 2. So parentheses squared equals m times 2. And we already know m is equal to, what do we get? 2? Yeah, 2x, or 2. Yeah, 2. So we got to put a 2 there plus b and a 2 here. So 4 is equal to 2 times 2 plus b, and b is equal to 0. Therefore, our question comes back to be, what does it come out to be? Hold on. Solve for b. B is equal, so we've got 2x plus 2x y, or f of x is equal to 2x plus 0, or 2x. And I'll be very, very surprised if that's correct, because this is a m is equal to 2 and b is equal to 0. Nope, we didn't get it right. 4 and negative 4. Well, we got 4. M is equal to 4. I guess I just didn't write it down right, because 2 squared is 4. Well, I messed up there. I'm sorry. 2 squared is 4. So I made a mistake on that one. 2 squared is 4. And when you plug it in and solve for b, you get negative 4. Not a good problem. Miss Holcomb or Hollister, not a good problem. But I'm glad you sent it, but this is not a test question. Oh, okay, that's all the homework questions I got. Any others? I don't see any. All right, let's move on. I want to move on with the power rule today. And there's 3 or 4 rules I'm going to teach y'all today. And this is 1.4, 1.5, and probably 1.6, but you need to look. Does anybody see their outline? What is the quotient rule and the product rule and the power rule? What does it say as far as those 3 things? Anybody got an outline in front of them? Yes or no?
Yeah, it's 1.5 and 1.6.
What is 1.6? Quotient rule?
The product and quotient rule, yes, sir.
Okay, 1.6 is the product and quotient rule. So that means 1.5 is probably the power rule. Does it say power?
Yeah.
Okay, and 1.4 is difference quotient / derivative, probably. All right, so let's make the transition. Let's do a simple one like we just did. This is a test question, so we'll put it down for a test question. F of x is equal to 4x squared plus 2x, and I want you to find f prime of x. I want you to find the derivative using the quotient rule and the limit theory. As h approaches 0. So that means I've got to do parentheses or brackets minus brackets over h. So this is 4 times parentheses squared plus 2 times parentheses minus 4x squared plus 2x. And I'm starting y'all off, okay? X plus h. All right, get to work. I just plugged in the x plus h's for y'all, so get to work. Because this is 100% algebra. Give y'all a minute. If you can't do it in a minute, then we all know what that means. Oh, crap. Nix, Mr. Nix. I got to send him a message. I got a meeting and he... Oh. How many of you have set an appointment with your advisor? Yes, no, maybe?
Nope, not yet.
Well, you better get on it.
Yeah, I've already had mine.
Good for you. Nix. N-I-X. I got somebody that's got an appointment at 11:30 and I've got a meeting at 11 o'clock, 11:10. So I got to send them a message. Need to make another appointment. My phone just went off and told me. Need to make another appointment. I have a meeting today at 11:10.
Hey, Hubert.
Yes.
I have a class at 11:10 too. I'm just letting you know that I'm here.
Oh, okay. Who was that?
Writings.
Oh, when did you come in, Miss Writings?
At like 9:50 something 10.
And
I'm sorry.
I'll put you down here in just a minute.
Okay.
Turn the volume down a little bit.
Okay.
I'm hearing myself talk. All right. I can meet after meeting, but don't know when it will end. Let me know. And I hope and pray that I don't know what to do about y'all's first names. The last 2 years, people's first names have become where you can't tell if they're male or female. I don't know what's up with that.
What's their first name? What's their first name?
Christian.
Probably a guy.
That that's a male, right?
Yeah, I would think.
I would think so too, but I'm gonna be honest with you, and it's not the kid's fault. It's not the student's fault. It's their parents' fault. By God, I'm not naming my kid Sue. I named my son James Walter Shambler McClure. I'm gonna make sure people know he's a guy. Anyway. All right.
You don't want to name him after a Johnny Cash song?
No, because I was named after a Johnny Cash song only. My name wasn't Sue. My name was Hubert. I would never name my kid Hubert. First through the 3rd grade, I got in so many fights because of my name. See, you got a nice name, Mr. Barry. Carter. That's a nice name. At least it ain't Hubert. Actually,
wait, Hubert, what's your middle name?
I played that song yesterday, Mr. Carter, or Mr. Barry. I played that song yesterday on my playlist. Okay, let me check for Miss Writings right quick while y'all were working. Miss Writings, student attendance, set attendance. I can't believe Tri-County hadn't kicked me off. It's a miracle. Anybody else show up? Wiggins, Taylor, let me look right quick.
Hubert, I got one more quick question.
Hold on just a second.
Okay.
Wiggins, Taylor, not here. I want to check this last. And Armstrong and Abdallah. Armstrong, nope. Okay, what was your question, Miss Writings?
I just gotta. I'm not meaning to interrupt class, but I'm just gonna ask it real fast before I gotta leave. But do you teach math 230?
No, and there's a story behind that. I did teach it, taught it for several years, but then Tri-County decided that all second level calculus courses was to be taught at Pendleton campus.
Oh my goodness, because I gotta take it in the summer, and I was like, man, I really hope I can get Hubert.
Yeah, I would highly suggest that you use Rate My Professor.
Yeah,
I
definitely.
can only tell you that there is one teacher that teaches it that she does do very well, but you got to make sure you pick her. And I can't tell you the name, but there's two she's, and one is terrible and one is not. So if you go to Rate My Professor and you get fairly decent ratings, then you're dealing with the right one. When you go to Rate My Professor and you get very bad ratings, then you know you got to get out. If it's a she. If it's a he, get the hell out. I can tell you that right now. Okay. So if you get a she, you got a 50-50 shot. So make sure you check Rate My Professor whenever you find out who you got for 230. Okay?
Okay, yes, sir. Thank you.
Okay. All right. So here we go. And this is 4 times x squared plus 2xh plus h squared plus 2x plus 2h minus 4x squared minus 2x. 4x squared plus 8xh plus 4h squared plus 2x plus 2h minus 4x squared minus 2x all over h, limit as h approaches 0. Take my red pen out, and the 4x squareds go out, and the 2x's go out. And I'm going to go ahead and take that h, and I'll take that one out, leave a h there, and take that one out. Limit as h approaches 0 of 8x plus 4h plus 2, and somebody tell me what you get. That means I want somebody to say something.
I got 8x plus 2. Is that wrong?
You are correct. 8x plus 2. This is f prime of x. That is the equation for the tangent line at any point on this curve. I'm sorry. Yeah, on this curve. So what does that mean? Well, we're going to take, I got to show y'all another toy they gave me. My little, ain't that nice? All right. I've been using it, but they finally bought it for me. I'm not using the trial offer now. And I'm going to put in 4x squared. I had to beg for this because people said, well, you got the x squared. Why don't you just use the one you got? Because this one's better for a virtual class. You get to see the actual keystrokes right here. See? Anyway, and that'll be blue. And we're going to 4x squared plus 2x. and graph. So there it is. So somebody tell me, you can't even see it, but at -3, what is my slope going to be? Well, let's just draw this sucker. Looks like it crosses the origin like right in there and goes up like this, like that, and this right there. And -3, we can't even see -3, but we know it's going to be negative. It's going to be a negative slope, sorry. So we know that this function is f of x is equal to 4x squared plus 2x. So what about at x is equal to 3? At x is equal to 3, what is, and I'm going to do a red, f prime of x is equal to 8x plus 2. Therefore, f prime of 3 is equal to 24 plus 2, which is what? 26, Hubert. So the slope at x is equal to 3 on this point up here is 26/1. Wait a minute. That should be -3. Thank you. X is equal to -3. So that would be a -26/1. All right. What about at +5? Or let's do +1. And 1 is right about there. So what is the slope of this line, this tangent to this curve? So that's going to be f of 1, which is equal to 10/1. So the slope of this line is 10/1. And the slope of the -3, well, we can't see it, but it'd be up here, and it would be like this, or it'd be steeper than that. It would be -26/1. Okay, now, if we take that slope and we take that function right here, and we apply the power rule of derivatives, then we can get this function without doing all this algebra and limit theory. And here is the power rule of derivatives. If I have f of x is equal to a to the n power, to find the derivative, I go and I bring this n out front, and that would be n times a, and then that will be n to the -1 power, and then that would equal whatever it comes out to be. So let's go back to the original equation, and that will be 4x f of x is equal to 4x squared plus 2x. Now I'm going to put x to the 1 right here because we got to do the power rule. And here's the power rule. F prime of x is equal to 2 times 4 x to the 2 minus 1 plus 1 times 2 to the x to the 1 minus 1. Now I just did this power rule right here. So I'm going to fold this up. Hold on. Well, I'm trying to fold it up. There we go. And I'm going to put it at the top of the page. Things I do for y'all. There we go. Okay, I just did the power rule. I brought the n out front, the 2 out front, right here. And that'd be 2 times whatever this coefficient is. And then n minus 1. 2 minus 1. I brought the 1 out front. 1 times 2, x to the 1 minus 1. And f prime of x is equal to 8x to the first plus 2x to the 0. And f prime of x is equal to 8x plus 2. And you get the same answer as you got doing all that algebra and all that limit theory. I'll give y'all a second to catch up there. Okay, y'all there? All right. So does everybody see what I did? Now there's a couple of things that you need to realize. Hold on a second. I'm getting bombarded with everybody. Okay, my daughter just took practice and she's telling me about it, and I got to tell her to call me back. All right, so 4x plus 2, does everybody see that? Does anybody have any questions? All right, what about this? F of x is equal to the square root of x to the 3rd power. Anybody got any ideas on how to do that one?
It would just be x to the square root, right? Because that would be x to the 3/2 once you change it to exponential form.
So yes, in other words, yes, you got the right idea. Radicals and calculus don't mix. What does that mean? That means you've got to change that radical into a what?
Exponent.
An exponent. Sorry. Radicals and calculus don't mix. So I need to change this to a rational function. F of x is equal to x to the exponent over index. Is that what you were talking about, Mr. Berry?
3/2.
And now you use the power rule, which y'all automatically will stop because this is a fraction and that locks you down. So bring that out front. 3/2 times 1, x to the 3/2 minus 1. And that's going to be 3/2 times 1 is 3/2. X to the 3/2 minus 2/2. 3/2 x to the what? 3 minus 2 is 1/2. And you can rewrite that as a square root. And that would be 3/2 square root of x. Or you could write 3 square root of x over 2. Now, I don't really care about these 3 answers. You can write them however you want to. Just know that you can write them 3 different ways because the homework or the test may want you to write it one of those ways. Now, the main thing about this, what did I do to this problem before I started? Rewrite. In calculus, sometimes you will make the problem a whole lot easier if you what? Rewrite it. And I just told you that radicals and calculus don't mix. So if you start off with a radical, what's the number one thing that you need to do? You need to rewrite it. What else? Anytime you have a variable in denominator. Anytime you have a variable in the denominator, let's do this one time before we get in class. F of x is equal to 3 over x. First thing you're going to do is you're going to rewrite f of x is equal to 3x to the negative 1. Now you can do the power rule. Negative 1 times 3, x to the negative 1 minus 1. Negative 3, x to the negative 2, negative 3 over x squared. F prime of x. Now, I just showed you, I think, and y'all help me out, what Miss Hollister or Miss Holcomb, what section does it say power rule? Is that 1.5 or 1.4 or what does it say?
It's 1.5.
Okay, so I've just covered pretty much 1.5. Okay. So I don't mind covering 1.5 and 1.6 slowly because the 1.5, 1.4, let me write this down for you. 1.4, 1.5, and 1.6, 80% of your Unit 2 test. Okay, so you better make sure you do these 3 sections of homework and you do them and you make sure you can do them upside down and blindfolded because 80% of your test is going to come from these 3 sections, which is the basic law of integration, which is the, doing limit as x approaches 0. Not integration, derivatives, sorry. This is the power rule, and 1.6 is the product and quotient rule. And I will test you on those 4 things. Basic derivative, the power rule, what we just did today right here. Let's see, how many questions did I do? I just did that one, and this one. Okay. That's 3 power rule. That's the power rule right here. So I give you 3. These are 3 examples of 1.5. All right. Everybody feel good? All right. I really want you to work on 1.5 homework. I really want to see some questions because I'm going to be honest with you. If I don't see any questions on 1.5, I'm going to move on to 1.6 because 1.6 is going to finish the 80%. Okay, I don't really care about 1.7 or 1.8 if we have to go that far. I really don't care about it because it'll be just practical application. Any questions?
No, sir.
All right. Y'all have a good day, and I will see y'all Thursday, and we'll finish up with 1.6 and maybe look at, I don't know, we'll be looking at a test after 1.6. How many questions, Ms. Hollister? How many sections are after 1.6 in the outline?
Just to 1.7 and 1.8,
Okay, what does 1.7 say?
the chain rule.
Okay, we will do that. And what is 1.8? Practical app?
Higher order derivatives.
Okay, that's just all three of, okay, so 1.8, include 1.8 on, 1.7 on that. The chain rule, we will cover that extensively also. So I will probably cover 1.6 and 1.7 Thursday. So be ready, okay? All right, see y'all Thursday. Have a good day.
You too, thank you.
All right, bye-bye.